All right, good morning.
Good morning.
My name is Orkhan. I'm co-founder of Startup Hype, and I spent 10 years building business intelligence tools and CRMs across telecom, e-commerce, financial institutions. Now, today we're going to tackle what I believe is the most important agentic AI problem. It's knowing that your agent, it's filling in the gap between knowing that your agent has problems and actually trying to fix those problems. So we're going to take a look at some of the tools and frameworks that you might have used, or some of them may be new to you. So we have, as I believe, two groups of people. Some of them are building agents actively, and some of them are planning to build those. So we will start with basics. We will start, that's the agenda for today. We'll shortly go over the basics so everyone is on the same page. And then we will enter the evaluation landscape. We will talk about, what works, what not, who uses what platforms. We will take a deep dive on GEPA framework. It's a framework developed by Stanford professors, class 329T, John Mitchell and Anupam Datta. Then we will cover optimization landscape, DSPy, and GEPA. And then we will look at the TEI, target, evaluate, improve loop. So this is the agenda for today. And of course, you will have a chance to share your own experience, and which is very much appreciated. So shortly with the basics, I was asked to show this part. So there's difference between observability and evaluation. A lot of people tend to use the same name for this, but these are different. Let's start with observability. So observability, let's look at the very simple agent. It's a customer support agent that does 4 things. So it receives, inquiry from the customer, our order hasn't arrived, it's been 3 weeks. Then it calls the lookup order with this particular shipment order, and then it checks the shipping status and generates the response. So 4 very basic things. So terminology here is that, every LLM request or LLM call is called a call. And the whole full agent execution is called a run. Logs of each run are called a trace, and several traces within conversation are called a thread. So trace is a very important word for you if you didn't build agents before. So make sure you know that. So this is an example of trace. Probably you can see it. And what observability does, it measures the logs of the trace. So it tells you what was the latency, what was the tokens, how many tools were called, were there any errors, how much did it cost, and etc. What observability does not tell you is how your agent actually did its function. How did it implement its function? Did your agent actually perform very well or not? Did it do its function or not? So that's exactly what evaluation does. Thank you. And let's look, for example, in the last slide, observability showed no problems. So, it looks like our agent is fine. It had no errors. It didn't take too much time to run. But look here, according to several metrics that we have here, target alignment, reasoning soundness, these are just random metrics for evaluation. We see that our agent actually didn't perform very well because customer wanted particular value based on his inquiry, but the response that he received was, your order shows as delivered on February 18. Please check in with neighbors, your building mailroom. If you still cannot locate it, contact this and that. So customer was asking something, but he did not get his job. So there's a big difference. Observability says there is no problem. Evaluation, says that, your agent didn't actually perform his job. So the customer was left without any path forward, getting a potential loss package. So this is just to be very clear. Now, again, just to summarize, this pretty much what the observability does, everything the evaluation doesn't. So these are 2 completely different terminologies here. Now, there is a paper some of you may have read. It's based on the survey of December 2025. So LangChain did a survey of 1,000 agent builders, and it was very important what others are building and what others are claiming the major problem is. And 32% of agent builders claim that the quality is still the biggest problem, which is very different from their perception from last year. Now, cost is the second most major issue, and latency is a third important issue. Now, importantly, it looks like everyone does use the observability. Everyone kind of uses some kind of platform. So 90% of the teams are using observability tools, but only half of the teams are actually doing structured evaluations. So at least using some evaluation platforms and etc. And only 23 of those combine offline and online evaluations. So just some of the trends here. So because the models are getting better and for other reasons, LLM as a judge starts to become almost as popular as a human feedback evaluations. So human evaluations are 60%, 60% of the teams are using human evaluations, and almost 53% are now using LLM as a judge. It also has to do with a lot of new frameworks that are provided for LLM as a judge to be used. Another reasons is just like, who is faster, gets on top. And with the human feedback, it's something that is necessary, but sometimes it's very hard to compete with the teams that are scaling much faster. So another important thing is that with new multimodality evaluations that are very necessary, the Gemini starts to get also some edge, because Gemini's multimodality capabilities can be actually topping those of Claude and OpenAI. So another important trend is that a lot of teams are not only doing evaluation and not only doing observability and evaluation, they're also trying to use some PROM optimizers, some optimization tools, and this is on the rise. So almost every major observability platform has the prompt optimization techniques. So just like I said, human reviews, annotations are going down, and LLM as a judge is going up. So that's kind of the trend now, and it's important to have it in mind. Yeah. All right. So this is the GPA framework. The paper introduced end of last year it's a paper by John Mitchell and Anupam Datta. These are professors of the class CS329T, Trustworthy Machine Learning. Anupam Datta may be also known. He's a founder of company TrueLens, purchased by Snowflake. So this paper actually finds that, just compares this particular framework of using this particular 7 LLM judges versus a single LLM judge. And it finds that this metrics like goal fulfillment, answer relevance, logical consistency, execution efficiency, plan quality, tool selection, plan adherence, and tool calling are actually able to catch almost 40% more errors than the single LLM judge. And they were doing this research using the Trail Gaia benchmark with 281 expert annotation errors. So it's particularly important when you are when you're looking at the low impact errors. So it's able to cover a lot of low impact errors. So I personally absolutely love that framework, and I am, even though it sounds like something very easy and simple, it yet does a lot of magic. So you may also want to try it. Also I was asked before just to quickly go over success targets and how we initially set this success targets. So if you have GPA dimensions, so these are the 4 dimensions that we use. Goal fulfillment has to answer the questions like, did the agent output satisfy the user stated goals? Answer relevance, supposed to answer, is the response directly relevant to what was asked? And logical consistency should answer if does each step follow logically from the previous one, and etc. But we have a certain targets here for each particular dimension, and the question is often comes up, like, how do we start? We have to, product, and we have to ship this agent very fast. What should be the target? And initially, the simple answer is just like, we don't really know. We don't really know with which one to start. So some of them, there is a benchmark, something that's unwritten, but yet starts to be used a lot by the agent builders, is knowing that when you start with key components, like with key metrics, like that can affect the user in production, then obviously the target there has to be very high. But if it's a recoverable error, then you may start with something like 0.8, and you slowly integrate and set it a bit higher and higher and higher. So in any case, measuring is the key here. You want to have at least 30 kind of iterations to try to start setting some benchmark. So the answer to this one is first measure. You still have to take time and add a bit of it as you grow your agent. So that's the answer. That's the way you're doing this. And this is the logic that was done all the way from the software development. So it's a Google SLO engineering context. That's pretty much it. So it's pretty much. So what is 0.95? It's pretty much saying that I'm okay with 1 out of 20 failing. Okay, but with the rest, I may not fail. So that's kind of the logic behind this. So what GPA does do, it does a better job in detecting 95% of errors. It does localize errors pretty well. What it doesn't do, it doesn't give you exactly particular information on how to fix those errors, and we're going to talk about that later. So it's like a doctor that perfectly diagnoses every disease. Now let's slowly go into the evaluation landscape, and here please share your experiments, your experience, what platforms you are using. I personally think that this slide may provide the highest value. So these arrows going up and down, these are like the trends that we believe are happening. I don't have official market data on this because these are just two different type of platforms. Some of them are commercial, some of them open source. But just looking at the GitHub activity and how much are they growing month to month, we can get some kind of idea. And we see that Braintrust, despite being very experimental platform, it got a lot of traction. Langfuse is like very favorite for all the starters. Comet, Opik, the fastest one, and so on. Slowly, I wanted to go over each one of them and to just read you aloud the advantages and disadvantages of each platform. You may be trying some of yours, and please, just raise your hand and say, hey, I am using this and this. I actually find that this is good or not. This can be very helpful. So this is a very default thing. Where you start doing when you do agents, you do start with LangSmith. And because it has a native zero configuration, full tracing, it has a large community, everyone knows about it, there's a lot of documentation. Now, once you start building on it, you kind of get scared that you're going to get tied for this platform. And then that's where the anxiety comes in, and you want to change to another platform. So what it doesn't offer, one of the most important things, is the self-hosting. It offers it in the enterprise tier. Which can be costly for some of the startups if you're doing a startup. And most importantly, for me, it doesn't offer direct integration with DSPy, which is a prompt optimization tool. So for me, it's a no-no. But it's known for the default choice for LangChain ecosystem and has some strengths and weaknesses. So the one on the rise that's getting all the hype is the Langfuse. And obviously, the key, the key advantages that it offers, it's self-hosting, it's an open telemetry native environment, and it offers you complete data control, which is especially important if you're building the agents that own a lot of customer data. So it's easier to get HIPAA and SOC 2 compliant. So some of the disadvantages is that some of the teams building on Langfuse, they start hitting some threshold where they say they're not enough capabilities on the platform, and we have to do something on our own, and our team is half non-technical, and then the teams, there's some problems, and they're trying to find new platforms that are able to provide those features.
Take a question.
Yep.
Sorry, this one is good. So you specifically mentioned it has a crucial HIPAA SOC 2 environment.
Yeah.
Does that mean the other evaluation framework don't have such capability built in?
Yeah, that's a great question. It's not really that they don't have it. It's just it seems like it's more friendly to operate in this way that gets you, HIPAA compliant. So it's not that every business process within that platform is HIPAA compliant. It's just a lot of teams say, I'm using Langfuse because I feel it will be easier for me to get a HIPAA compliant, to get all.
Friendly.
Yes, it's more friendly. Yes. Yeah.
Yeah. I have a quick question. What is the reason it's for the smaller ecosystem than LangSmith?
Great.
Because it's from the regulated zones?
Yes. It's for regulated. It's very good for regulated industries. It's particularly some sensible industries. So the key point of the Langfuse is data control. So you own the data. It's not somewhere on the LangChain and so on. So a lot of teams think to start safe, even though it doesn't have all the features. But it gets you the most important thing, which is self-control and data ownership. Yeah. Now Comet Opik is another fast one. It has Apache 2 open source. It's claimed to be 7 times faster train logging. So it's like the fastest way to start. You can connect a lot of data very fast with Comet. Some of the disadvantages that it has a relatively smaller ecosystem yet because less documentation and limited trace level analysis for complex workflows. So we have a very complex workflow. You may also look at another ones like Phoenix and so on. So this is a very popular one, Arize AI. Arize AI is known for its seamless data lake integration. And it's known as an enterprise observability leader. A lot of enterprises using Arize. Arize is something that data scientists love. So it also offers open telemetry and it excels for RAG-heavy apps. And it offers enterprise-grade security and compliance. Now, yet in comparison with Langfuse, LangSmith has a little bit smaller developer community, but it's growing. Now, there's a Braintrust. Braintrust was a very interesting one. So if you have a lot of non-technical people in your team, and probably a lot of product managers, then they would definitely love the Braintrust because it offers you a great, very easy UI and a lot of experimentation. Some teams say that it offers experimentation, features where there doesn't need to be experimentation. Like it offers prompt experimentations on very early on. But I don't know. I think time will show how well Braintrust does. I actually find this experimentation pretty good. Yeah. Another thing is a closed source SaaS, so you may also take that in consideration. DeepEval is known as a quick start champion, has 14 metrics with minimal setup. So it's a very fast and easy setup. Yeah, it's less comprehensive for full enterprise control in comparison with Arize, but it has its own features that you may want to, it's fully customized for the Python users. So Yeah, I forgot to mention, I think, that Braintrust also offers, if you're using TypeScript and JavaScript, then the Braintrust also may be a good option for you. Well, Ragas, name saves it all. It's customized for the RAG evaluation. It's not really a platform, rather it's a package. So it doesn't offer all this UI. Team has to be a bit technical, maybe. Doesn't need how to code. It offers Apache too. So it has well-documented community, and but it doesn't have really a lot of experiment tracking or reviews quite. Yeah. I'm going into the optimization landscape, which starts. Yep. I wanted to ask, can you raise your hands? How many of you are using DSPy? If you're using DSPy. No, not anyone. All right. Yeah, you didn't, but you will still hear soon a lot, depending on what the agent does, of course. Because I mean, it's really all of these platforms and your relationship to these platforms. It has to do with what your agent does. I mean, like it's not just like I'm using the DSPy. Maybe you don't even need it. But so this is like optimization tool. Well, the name of this slide shouldn't be maybe market share because there's no market share here. But DSPy has 33,000 GitHub stars. It's something from Stanford. It's a prompt optimization, let's say, framework that is completely different to prompt engineering. So it's the other opposite direction from the prompt engineering. So it totally changed the game in this way. So I will just start with DSPy. So with DSPy, you don't type any prompts. You don't change any prompts. With DSPy, you tell DSPy what you want, what the user model wants to achieve. And then the model does it, then the framework does it on its own. So the key terminology here is called signature. So this word signature and DSPy often used in the same sentence. So you determine what is the signature for your agent. You mention that signature, and then let me see if I have somewhere. No, I didn't. So you just mention a signature, and DSPy makes everything for you. It generates the prompts based on the signature. So it's more technical, and it doesn't. I should have added some kind of examples here, because I was just sure that most of you have used this DSPy. But the key component here is that there's zero prompt engineering, and you stop using doing prompt engineering once you use DSPy. Now, within this, DSPy is like a car that may have different engines. So it's just a framework. And the actually engine that is generating and picking up the right prompts are the optimizers. And there are different optimizers that I mentioned here. It's default optimizer is called MiPro v2. Then there's a Bootstrap, GEPA, and Simba. So DSPy claims that it can improve efficiency from 25 to 65% of your agent based on the metrics you use. So it's very strong prompt framework. And MiPro v2 was a heavily used optimizer because it was a default version. Also, DSPy comes from Stanford. But then the last year, the GEPA came out. I hope I'm not going too fast. And I will start speaking about GEPA soon. Yeah.
For the optimizers, how does it evaluate the output? Is it using an LLM as a judge?
Yes. So it does use LLM as a judge, but the mechanism inside is much more complex, and we will have here the GEPA's algorithm, and then we will cover this. So I just want to, I don't even know if it makes sense to say what LangSmith's prompt team, prompt feature do, or the Braintrust loop does, because it's comparing to DSPy, this seems like, it's a handgun versus like, the Gatling. That's, it just makes no sense really to even compare them. The key here in DSPy, you never manually write a final prompt. The system compiles the optimal instruction, and you've showed examples for a specific text and model. So, yeah.
Can you go back?
Yeah.
So the adapters, are they same as optimizers? Because it's just adapters.
Not exactly, no. Once I show I'll show this one, it will start to be more clear. Yeah. Yeah. So the default optimizer, these optimizers are what makes the difference within DSPy. This is MiPro v2. How does it work? So again, we have this customer agent example where was our order for 821. So it runs our support agents on a lot of queries, and it keeps keeps the 50 traces where it scored the highest. So it does really look at like you said, it measures everyone. It takes a lot of time. It takes a lot of cost, honestly, but it measures every trace, and it just keeps like the top scoring ones into the pool. The important here, I think, is that it's once a particular prompt, it can increase one metric, but it can decrease another one. So that's why they have a pool, because each metric scored on all these dimensions that we have. Now, the optimizer sees the system prompt and the 50 good traces, and then proposes particular prompt. In this process, you usually there's a certain logs where you can see the prompts generated, but it's a much less different environment for the teams who are working on this, because they rarely look through all the prompts generated, because sometimes they're just like thousands, so you really just have to I trust the DSPy. Let me see what it comes back tomorrow. Yeah.
For the prompt optimization, if you have an agent, there can be kind of many layers of prompts. There's your overall agent plan and how you instruct the agent, and then there's the tool description, and
Yeah.
your subtools and whatever. Is it optimizing all of those at once, or do you pick a particular area you want?
You pick particular metrics. You definitely particular metrics. You make the signature. That's what the signature stands for, and then it just works in that direction.
Okay, but it could be changing any of those. If you decide, your problem is you have a poor tool description.
Yes. Yeah.
It sounds like you use this in the beginning to come up with some good prompts. And can you also use this once you have a deployed system and you have real traces?
Yes.
Use that data back in?
Yeah, you can do it, but you have to be careful, because the DSPy, you have to use it on a cloned version. So, because it can make changes to your agent. So just make sure that you have everything set up. I always clone the environment that I have in, and I just use this on it. Yeah. So yeah, and here comes the GEPA. The last year, it's a big paper. Actually started as a framework, probably then as a paper. There are several universities involved, Berkeley, Stanford, MIT, and Notre Dame, but I think originally it comes from Berkeley. What it does is it uses MiPro v2, mathematically it uses the Bayesian approach towards evaluating which prompts are the best. And the GEPA is using the genetic Pareto, with Pareto frontier. And this has changed. I would definitely advise you to try the GEPA, at least have it. Personally, I will start with my personal experience. It did change things for us in some metrics. We saw improvement everywhere. For us, it was about an average, we just across all dimensions, I would say it was 5%, something like that. which is already pretty good, I think, because we were working on it, for a long time to optimize those prompts. Pretty much a lot of teams, once they start using GEPA, they just like tied to it. Like Shopify and a lot of big brands right now are using this. And in the environment where your agent has to do a lot of new features, it offers the customers a lot of new, there's very varying, fast-changing environments for your business. GEPA is very important. Now, just like DSPy, just like MePro V2, GEPA also takes a lot of time to do, but it still uses almost 35 less rollouts than the other DSPy optimizers. So it's much more, it takes much more cost and time efficient than the other ones. It does take, in any case, it will take you, 3-4 hours at least, depending what your prompt budget is. But in comparison to the other ones, it's just so much better. So it really did produce for us better results at less cost. So this is actually, I just borrowed it from his own presentation. So he says like the problem it solves, like prior learning techniques only consider numeric scores as learning signal observed at the end of long-running rollouts. But GEPA uses reflection, so it means that it uses domain-specific textual feedback as learning signal in addition to numeric rewards, making large updates from one rollout. So instead of just getting a reward score, we obtain a score and a text feedback why the score was like that. And that's the major difference with MePro V2. So prior prompt optimizers propose all new prompts upfront to perform Bayesian search over them, and GEPA assumes that good prompts are derived from previous good prompts, building a tree of prompts that improved upon each other. So again, the pool of prompts is used here, but for every prompt, GEPA saves all the additional information, not just the score. Like why the score was bad, how would it improve? It's just like a data point with a lot more data points around it. So, let's finally get to the algorithm. I don't know if you can see the algorithm very well. Can you see it? Yeah. I'll just read. Yeah. So the candidate pool starts with seed prompts. Each prompt is scored per training instance. Then the Pareto frontier keeps every prompt that is best at any single task. And GEPA uses two mutation strategies. It's reflective mutation. So reflective mutation reads a failed trace, uses LM to diagnose a specific problem, and propose a new instruction. And system-aware merge combines complementary strengths from two candidates. Then a new candidate enters pool only if it improves the Pareto frontier. Each prompt inherits lessons from the previous one, accumulating fixes across the genetic tree until the prompt budget runs out. So it's much more complex, but it's very useful. This is the comparison of GEPA versus other optimizers from DSPy. As you can see, so GRPO is not a default model, but some people did use it as well. So this GRPO uses so many more rollouts, and GEPA is producing, outperforming a GRPO by 10% by using like 40 times less rollouts. Just to make sure, what time is it? 15? 15, okay. So the action gap here is, every framework tells you what to do. Some of them even offer you how to fix them. But, there's little tools that actually fix them automatically. Braintrust tries to become one of them, even though it's not for all the teams, that you need to fix things automatically, because once you already have the product, you cannot just like risk it and just iterate the CI/CD approach. But If you're starting and you need high experimentations to get you on a good ground, then maybe it's a good idea to have such a tool. So we just made our own tool, and I think a lot of teams are coming up with their own tools. What we try to do with this tool is we try to combine what we learned in GPA and GEPA. It's not exactly a copy, but it's something that we try to inherit from both of them based on the knowledge that they have gave to us. We're still in the process of doing more research and iterating with this. We don't have enough. We only have tested on 28 production agents, but there's some improvement. But we're still iterating this one. So as you can see, this looks very similar to GEPA's, especially in the prompt optimization. So we try to use the Pareto frontier here. But what the difference is that with TEI, target, evaluate, improve, it's a package that allows you, your agent, to get evaluated. Then if there are core structural fixes that need to be done, the improvement work is divided in two works. So it's the first one is structural fixes, and another one, the prompt optimization. The way we divide this is the structural fixes have the certain targets that we have talked about earlier. And once it hits those targets, or once it doesn't do the targets, those dimensions have to be improved through structural fixes. And once those targets are achieved, it moves to the next phase, which is a prompt optimization, and it's using a similar Pareto frontier methodology to optimize the prompts. So I will run a short recorded demo, so you can see this. This is just.
So we run TEI, and in step 1, TEI scans the agent source code. It reads through the file, identifies the main function, finds the system prompt, and places checkpoints at the key decision points. Things like where the LLM is called, where the data is injected, where the response is returned. Now, in step 2, it runs the agents with a test query and evaluates the response across 4 dimensions. Target alignment, did it answer what was actually asked? Reasoning soundness, is the logic correct and well structured? Execution accuracy, did it use the right data? And output integrity, is response complete and grounded in facts, not hallucinated? These are 4 P4 scores. This is what the agent looks like without any help from TEI. Now, in step 3, it does structural fixes. So, this is a structural improvement. TEI proposes code-level fixes, things like adding error handling, improving how data is passed to the model, or tightening the control flow. It applies each fix to a clone of the agent, runs it, and checks if the scores improved. If fix makes things worse, TEI rolls it back automatically. Only net positive changes survive. This runs for iterations, so it takes a few minutes. Now, in step 4, we have the middle evaluation. After structural fixes, TEI runs a fresh evaluation. We call this middle evaluation. So it shows us what improved from the code changes alone. Step 5, proposed metrics. TEI proposes us new metrics. Pretty much TEI looks at what this specific agent does, customer support, order looks up, return policies, and proposes task-specific quality metrics. Not generic one, but tailored to this agent. For example, does the response reference the actual order ID from the database, or does it address every sub-question the customer asked? These metrics become the objective function of the optimization. Now, in step 6, this step measures how the current prompt scores on each of those metrics. This gives us a quantitative starting point. Step 7 is a prompt optimization. This is the core of TI's improvement agent. It uses two strategies. Reflective mutation, where it analyzes why a metric scored low and rewrites a prompt to fix it, and system-aware merge, where it combines the best parts of two different prompt candidates. Each new version is tested and scored. The best ones form a Pareto prompt, just like you saw in GEPA, a set of candidates where no single one dominates all others. Over 30 iterations, the prompt gets progressively better. And critically, TI checks that no individual dimension score decreases. If a prompt helps one area but hurts another, it gets rejected. So in final report, we have the 4 dimensions side by side, baseline versus final. We can also see the task-specific metrics and how much they improved. The key quality, TI never lets any dimension regress. So every score either stayed the same or went up.
Yeah.
And the
So yeah, that was just we didn't use the actual agent here. It was just something for the it was imaginary customer support agent that we used in this particular time. So don't look at this execution accuracy. It just didn't have really the endpoint to measure. So overall, the delta should be lower than this, but it's still an improvement. So if you ignore the execution accuracy, 67%, then you can still see improvement in target alignment, reasoning soundness, just after the 30 iterations. So what we're doing here is actually just repeating things we learned in GPA and GEPA and trying to, do it our own way. And maybe as a team, who are building these agents, you can do it yourself. But it depends on how much of the data control you want, how much you want a customization you want, and etc. So, yeah, I think we should have time, right? Okay. Yeah. If you have any questions, we can see.
We have access to your presentation.
Yeah, I will send to Barrett I will send the access to the Barrett, so you can try all of this. Probably I will send you the presentation together with access to the TEI and so on. I just want to mention that for this 30-round iterations, we used the Anthropic, we used the Claude Opus, and it took us about 50 minutes, and it costed $11. So just know that if you're gonna use it, you can add the iterations if you're not satisfied with what you receive during the process. But all it costs your own, API keys. So that's the cost. Yeah. Yeah.
When you want to run this on more than a toy example, you have to have a way for it to easily clone the environment. For example, there's order lookups, you need a database with order, you need an API that can serve that. Do you clone that for iteration, or do you have one instance of that and where agent clones can all
Yeah. The best thing to do is to try to put it into one Python file. Just to if you can. Yeah, that's a very good point actually. The key point to put it into one Python file. In any case, it will not even use that Python file. It will just clone the Python file, and it will run all the iterations on the cloned version of this Python file. But you want to prepare it yourself in the beginning. Yes. Yes, because it will run into the problems when it doesn't get to the access of your own environment.
If I have a multi-agent system that has a multi-collaborative agent and some main agent has sub-agents and tools, so in a total solution or product, and let's say hypothetically I have 8 agents, 8 prompts, how is this system applied to self-evolving and testing evaluation?
Yeah. So in the example that you mentioned, there are 2 risks. The first one is the endpoint risk, and another one is the memory risk, right? It's just the capability of the model itself. In this case, TEI will need a customization. For example, one of the solutions that I can see is that you can use additionally something like a Graphon. It's called Graphon API. So it's like a memory extender, pretty much. If you're working with a huge, environment, and there's like tons of code and tons of things to consider, you need, just the typical Opus, the context window of the Opus may be not enough for you.
Right.
So you will need something like a Graphon, probably.
That's how you think to approach the problem, not to address one agent at a time.
Yeah. Yeah.
To
Yeah, you will need to probably to increase the memory of the. Yeah.
The example you specifically gave in the video.
Yeah.
That is basically
Yeah.
one agent, one prompt.
There were several prompts, so there were several prompts, but it was just one file.
Sub agents.
Yes.
And each has a prompt.
Yes. Yes.
Okay. Like how many are we talking about?
I need to look at that. There's a JSON file.
Which is
I can share that JSON file as well with Barrett, and you will see the before and after, and you will see all the logs of what happened are included in the JSON file. So you will be able to compare it with your own environment.
Thank you.
Thank you. That's it. All for today. Thank you.
Thank you for the presentation.
Thank you.
I'm sorry, I'm Alex from
Orkhan,
Braintrust.
we met at the StartX event last time. Yeah.
Yeah. So I missed the beginning of the presentation. It's
We were just covering the basics, like the terminology with tracings, because I was asked to cover the basics, so we're all on the same page.
I see.
You didn't
I
miss
see.
much.
So for your company,
Yeah.
what's the purpose of doing this presentation? Only in the spirit of sharing, or your company is actually
Only in-
promoting
No.
like